Hello, this is day 2 in our lesson on hyperbolas. We're going to be looking with the center of the hyperbola moved off the origin to some hk value. So we're using transformations again. And you see in our models here that you have the transverse axis being on the horizontal or the transverse axis being on the vertical. In each case, you may want to turn off the video and copy down the equations that we're going to need for our last lesson today. And then join me back here for example 5 when you're finished. All right, moving on to example 5, we want to graph the hyperbola, and notice that our first term is y, so our a value is 3 and our b value is 4. So we know a is 3, b is 4, and 9 plus 16 is 25, so the square root of 25 is 5. Since the y value is first, the a and the c are vertically oriented and the b is horizontally oriented. Our transverse axis is vertical. And the center, be careful with the center because you want your hk value, and h goes along with the x coordinate, so that's 2, and k goes along with the y coordinate, that's 3. So let's go create our box around 2, 3. So 2, 3 is our center, and a is 3 units up and down, and b is 4 units right and 4 units left. So those are our vertices. They're going to create the boundary box that we need. And next, after the boundary box is created, we want to put the asymptotes in. So those go along the diagonal through the center and help us to have some boundary for how the branches on our hyperbola will be situated. So we've got those going through. Next, we can put our major vertices. That would be at 2, 6 and at 2, 0. And our minor vertices would be at -2, 3 and at 6, 3. And then we can put our branches for our hyperbola in vertically oriented through 2, 6 and 2, 0. And the foci are 5 units from the center, so we go 1, 2, 3, 4, 5. That puts that focal point at 2, 8. And then 5 down would be our focal point at 2, -2. And then lastly, we want to create the asymptote equation. So in this case, our rise over run, the rise is 3 units up and run is 4 units to the right. So I'm going to use the equation up here, this equation and this equation, or this expression and this expression, to put together the idea we have of y equals mx plus b. So we can set that up by taking the y term, the y minus 3, that's this portion, y, and we know the slope is either positive 3/4 or -3/4, depending on this asymptote or this asymptote. So we've got that. 3/4 is our rate of change, and then that's the m part, and then the x part is the x minus 2. And if you solved out this particular equation for either the positive 3/4 or the -3/4, the b value would be collected at the end, and you would know the exact equation for each particular asymptote if you needed to know where it's crossing the y-axis. And that is example 5. For example 6, you can see we're going to use the graph and the boundary box to put the equation together and work backwards from the graph. So since our axis, our transverse axis, is horizontal through the y equals 1 line, you can see the center of our hyperbola is located at 2, 1. So we know the HK value is 2, 1. And we can determine that the A value is 1, 2, 3. The A value is 3 and the B value is 1, 2, 3, 4. So we know the A value and the B value, and then we can calculate the C value. So A is 3 and it's oriented horizontally. I'm about to draw the wrong direction here. It's oriented horizontally. And the B value is oriented vertically, and that was 4. So 9 plus 16 is 25, and the square root of 25 is 5. So we could put the equation together as x minus 2 quantity squared over the A value squared, and y minus 1 quantity squared over the B value squared, and that difference is equal to 1. So our foci, we're already 3, so 5 away is 2 more. This first focal point is at -3, 1, and the second focal point is at 7, 1. And then our asymptotes, let's count the slope. So we've got a rise of 4 and a run of 3. So our slope value is 4/3 this way and -4/3 this way. So taking the y expression, y minus 1 equals plus or minus 4/3 times the quantity x minus 2. So we've worked backwards and put all of the important information together about this hyperbola based on things that we know in the behavior of the graph. For example 7, let's find the equation in standard form of a hyperbola with a major vertex point at -2, 4. So we know a major vertex point at -2, 4. So let's sketch that in there. And we know that the asymptotes are at 3/2 x plus 4 and -3/2 x minus 2. So we could draw those in at 3/2 x plus 4. So we're going to have a B value at 4. This is my B value. And rise 3 and run 2. 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 So we have an asymptote going through here. And then our next one, the second B value is at -2. And we have a negative slope of 3 and 2 left, up 3 and 2 left, up 3 and 2 left, and go the other direction to right. So we have an asymptote that goes through here. And you can see we passed through the center. This is our center point here at -2, 1. And you can tell that this dotted line as I go through this major vertex point that we are how far away from the center. 1, 2, 3. So we're 3 units up from the center. This is going to be our A value. So 3 units on the A value. And if we go 3 in the other direction, 1, 2, 3, this would be the bottom of our boundary box. You can tell how nicely they line up. And this is the side boundaries. So our transverse axis is vertical. and the b value is 2. It's going left and right. And squaring 3 and squaring 2 and adding them up, 9 plus 4 is the square root of 13. So it's got to go this way. And let's see what else. We need to put the equation together. So square root of 13 is going to be a little bit more than 3. So we're up here, first focal point, and down here. And the branches are on the vertical orientation. So one branch here and another branch here. And let's practice how we get to the focal point. So starting at the origin, we would go -2 left, 1 up, and then add radical 13 to that y value. So putting that together, we go -2, and then 1 up, and add the square root of 13. And then trying that again, first we're going to go -2 up, to the left, 1 up, and then subtract the square root of 13, and then we're there. So that second one is -2 and 1 minus the square root of 13. Okay, so finally putting standard form together, we want y terms first, so y minus 1 quantity squared over the a value squared, and then x minus -2 squared over the b value squared equals 1. Now I've already set up example 8 for completing the square like we did with our ellipse lesson. I organized the x squared and x term, and then the -4y squared and the positive 8y. I took the negative out and made sure that negative was taken care of on the y linear term. Next, we want to take out the leading coefficient from the x squared and the y squared, and also divide it from the linear term. So getting that set up, we have a 9 on the outside with an x squared plus 6x, and completing the square, half of 6 is 3. 3 squared is 9, but we're adding 9 times 9 to this side, so we're actually adding 81 to the right side in that case. Then on the next set, we're going to take out -4 and take that from the 8 would leave us 2, and then completing the square, half of 2 is 1. 1 squared is 1, but we've got -4 times 1, so we're actually subtracting 4 from both sides. Cleaning that up by factoring, we have x plus 3 quantity squared minus 4 times y minus 1 quantity squared, and 81 minus 45 leaves us 36. So dividing each term by 36 in order to create a 1 on the right-hand side is going to leave us with our standard form equation. So this standard form is going to be x plus 3 squared divided by 4, and y minus 1 quantity squared divided by 9, and that equals 1. So here's our standard form, and the center is at HK, and the H belongs with the x term, so we have -3, positive 1. So let's see, our A value is 2, A is 2, B is 3, and 9 plus 4 is the square root of 13 after we take the square root. So putting this together on our graph paper, we have a center at -3, 1, and we have a values that are 2 units right and 2 units left, and b values that are 3 units up and 3 units down. And we'll draw that boundary box around the center and through the vertices, and then create the diagonals for our asymptotes to help us draw the branches correctly. And then sketch in our branches that stay nice and close to the asymptote and through the major vertex point of -1, 1. And then same on the left branch, close to the asymptote, through the vertex point, and on around, and that vertex point is -5, 1. And then our minor vertices would be at -3, 4, and the other one is at -3, -2. Now let's put the foci in here. So starting at the origin, we want to go -3 to the left, and then add square root of 13 and go up. So we'll be right in here. So we went -3 to the left, and then we added the square root of 13 and went 1 up. So we're right about there. And then doing the same thing to get to the next one, we're going to go -3 left and continue to subtract square root of 13 and 1 unit up. So this last one will be over here. So this was our first one. This one is the second focal point, -3, and continue negative, and then 1 up. And finally, last is our asymptote. So starting at the center, our rise is 3 and the run is 2. So 3 over 2 is the rate of change. And it's in y equals mx form. So what the y term was y minus 1. So putting that together as an asymptote, we have y minus 1. Y minus 1 equals the positive or negative slope, 3 over 2, and the x term was x plus 3. And that puts an end to our lesson on hyperbolas. See you next time.